Welcome to the session 4 of research introduction. In the previous session, we have seen research process. What is research process? Its criteria, characteristics of research problem. We have defined the research problem. Then we have gone through the criteria for selection of a research problem, good research problem. Then how to evaluate that research problem. Then the common mistakes or errors while selecting the research problem and scope of research problem, and then research of aim and research objective. These points we have discussed in the previous session. Now, in today's session, we'll revisit the research problem definition and its points. Then we'll discuss what is the necessity of defining a good research problem. Then we'll see choice of research area. So this is very important when for a researcher while starting his research. So we'll discuss upon choice of research area with some illustrative examples. Then research area in electrical engineering, especially for power system and power electronics specialization. Then finding a research problem. We'll discuss some of the tips. So what are the ways so that we can write a good research problem. So these are the contents of today's session. So in the previous session, we have discussed that research in common parlance refers to a search of knowledge. We have seen this definition. Research is nothing but search for knowledge. And one can also define this research as scientific and systematic search for pertinent information on a specific topic. So it is an art of scientific investigation, right? Or the Advanced Learner Dictionary defines the research as a careful investigation or inquiry, especially through search for new facts in any branch of knowledge. And Redman and Maury define the research as systemized effort to gain new knowledge. So these are the formal definitions of research. So mainly search for new knowledge or search for knowledge is one word we can refer for the research or art of scientific investigation. Now, what motivates or what motivations are required in research, or what makes people to undertake this research? So this is again fundamental question, and we all came to this question. And the possible motives or motivations for doing research may be either of the following statements or following motivations. So one is to the desire or need to get the research degree. Like if a bachelor's candidate or student is there, he will try to go for higher studies and take the master's degree, and during that he perform some kind of research, and then master students go for the doctoral degree, and for doctoral degree the research is a must. And not only that, along with that degree, the researcher gets consequential benefits, maybe in terms of the knowledge, recognition, and the appreciation. This is one of the motivation. Second motivation is desire to face the challenges in solving the unsolved problems. So some researchers take research for solving the unsolved problems. So they take it as a challenge, and the concern or practical problems initiate this research. So it may be theoretical or it may be practical. So if we take to solve some real life problem, so that is also one of the motive. Then desire to get intellectual joy of doing some creative work. When we do some creative work, so it will generate some joy in ourselves or in the researcher. So this is another motivation. Then one motivation is desire to be of service to the society, desire to give the service to the society by solving the societal problems. So So this is another motivation. And then last one is to get respectability. When someone completes or someone performs some research, some kind of research, and then he get recognition, appreciation. Along with that, he or she get respectability in the society. So these are some of the motivations, and for any researcher, one of the motivations will be there. So in most of the academia, we see degree is one motive, so that every faculty or every professors go for research and complete and take the degree. Now, research problem. So for doing the research, the uppermost or the initial point is research problem. So it is most important than the solution. So if you define the problem, research problem properly, then almost we have done the 50% work of that particular research, and it is more important than that particular solution. So generally it refers to some difficulty which a researcher experiences in the context of theoretical or practical situation and wants to obtain solution for the same. So this is the definition of research problem, or in simple words we can say it is a concise and precise statement, problem statement, which is undertaken by a researcher to find the solution. And a problem problem area, in the research problem we need to identify the research areas. So how we can do that? So here is one example is given. A problem area is an area of interest to the researcher where some aspect or some aspects are still to be studied to find a complete or even partial solution to an existing or an anticipated unanswered question. So it may be possible that some questions are unanswered, so one can take this as a challenge and try to find out the solution. Or it may be possible that some aspects of that particular problems are already been solved by some other researchers, and then to solve those remaining aspects or partial solution, one can go for this research. Or it may be possible that already some solutions are available and one can take this research for getting more efficient or more uh, proficient solution for that particular problem. And this is the objective of research. So different scenarios we have discussed here. Now, how how we can take a research problem, or where we can find? So here one illustrative example is given. So we know that 6 equal to 1 plus 2 plus 3, or 28 equal to 1 plus 2 plus 4 plus 7 plus 14. So do you find anything typical about this? Because here you can see 1 plus 2 plus 3 is equal to 6, and 1 plus 2 plus 4 plus 7 plus 14. This is also equal to 28. And so these are called perfect numbers. Why? Because these are natural numbers and these are expressed as sum of their divisors. So if you can see the divisors of 6 are nothing but 1, 2, 3, except 6. So except that own number, all other three numbers are adding and giving the same number. Also these are the divisors of that same number, like 1 is divisor of 6, 2 is also divisor of 6, 3 is also divisor of 6. So similarly if you find 28, this sum of all these five numbers is 28, as well as these are also the divisors of 28 except that same number, that is 28. So that's why these are known as perfect numbers. Now, similarly, the next two perfect numbers are 496 and 8218. 8218. So 496 and 8218. So these are very rare numbers, and Euler proved Euclid's observation that all even perfect numbers are of this form. That is, through the research, Euler has observed that all the perfect numbers are even, and those are of the form of 2 raised to n minus 1 into 2 raised to n minus 1, where 2 raised to n minus 1 is a prime number, and this is called as Mersenne prime. So such only 49 numbers have been identified till 2016, right? So number systems, we know that there are infinite numbers, but only 49 such numbers have been identified or found till 2016. So the number of perfect even numbers is only 49. Till today, no odd perfect number has been found. So this is a problem, right? So some or partial solution, we know that perfect numbers are even, but there might be possibility of odd perfect numbers, but those are still not found. So no proof exists to deny the existence of an odd perfect number. That means there is also not possible that there does not exist. So there may be existing the odd perfect numbers. Now here comes the problem. How do we find the subsequent perfect numbers? Can we develop an algorithm for this purpose? So can we find out the perfect numbers, odd perfect numbers, or can we develop an algorithm so that we can identify the odd perfect numbers, or can we develop an algorithm so that we can identify next even perfect numbers? Only 49 numbers are known, but we can go for further numbers also. So this is the problem. So an attempt to resolve this problem was undertaken by Acharya Bhojendranath C by defining the coefficient of a natural number as like sum of all its divisors except itself divided by number. So this is how he has defined. Now, unfortunately, coefficient of successive numbers do not reveal any pattern. So there is no fixed pattern, and we have no clue when this subsequent coefficient will equal to one, and this continues to be a research problem. And so, like this is one kind of research problem where we have identified that certain solutions are available or observed by the previous researchers, and there is still scope to find out the further solutions. So this is an illustrative example of research problem and area. Now there may be question, what do we gain by solving this kind of problem? So we should reconcile ourselves to the fact that uh, these are all these are conceptual and arising primarily from curiosities. You may be telling that what is the necessity of finding perfect numbers. So there there are real life examples where those are related with these perfect numbers, but so these are motivated by some real life problems, and to solve those real life problems we need such perfect numbers, and that is the motivation, and that is why this research problem is important, or this is having some significance. However, solutions to such problems have found extremely important in resolving some complicated problems also. So it may be possible that we need help of perfect numbers in solving real life problems, or it may be possible to solve some complicated problems of research. It may be conceptual or it may be practical. Right. So this is the importance. Now, after seeing this research problem, so what is the necessity of defining this research problem? Because the research, as I earlier mentioned, that the defined research problem is have solved your problem. The problem to be investigated must be defined unambiguously. That means there should not be any ambiguity, and the research problem has to be concise and well defined. And it will help to discriminate relevant data from the irrelevant ones. There may be a lot of information which may be which may have some relevant data, irrelevant data. Once we define the research program, we'll discriminate what is the relevant data and what is the relevant data. Also, a proper definition of research problem will enable the researcher to be on track. If we define the research problem properly, and then researcher will be always on the track. What his aim is there? What are the researcher objectives? So that he will keep the track of that particular objectives to achieve that aim. So an ill-defined problem may create hurdles. This ill-defined problem may create chaos, and halfway through, that researcher may lose his interest in doing that particular research, and he may discontinue. So, how we can verify this? So you can ask questions like, what data are to be collected for solving our research problem? What characteristics of data are relevant and need to be studied? So there may be n number of data, but only n minus or p number of data is important where p is less than n, right? So what relations to be explored, how we can relate these two, what techniques are to be used for this purpose, and similar such other questions uh, come in mind of the researcher. We can well plan his strategy and try to find out answer to all such questions, and then he can define his research problem. So through these questionnaires, one can frame his research problem and make it precise and concise. So this is up as prerequisite for any study or any research. That is, defining the research problem properly is the prerequisite for any study and is the step of the highest importance. If it is defined properly, then only we can keep our research on track, and this is the highest importance. If it is not defined properly, then we may stuck in between. Now, while defining this research problem, again, it depends on field to field. If the researcher is from arts, if he is from science, if he is from technology, so how we can choose the research area? So here are some points that researcher think of some problem of interest in domain knowledge. If suppose an engineering researcher is there, he may think of his particular interest area. Again, in engineering, there are fields like electrical, mechanical, civil, or computer science. So one can define or one can select his problem of interest and then start working on it. Problem choice was motivated by a critical survey of the existing literature, or it is generally felt importance of the problem, or perceived appreciation of even partial solution to the problem, or sometimes the perceived ease of completing the research in relatively short time. So these are some points, like say for example, the take the research area selected by the researcher is motivated by a critical survey of existing literature. If already such existing literature is available, and after going through that and doing the survey, one may be motivated and take up that problem and start working on it. So this is one possibility. Or it may be possible that that problem is important to that particular domain, and then he can take up that as a research area. Or it may be possible that some uh, even partial solution of that particular problem may give the appreciation. So this is one of the reason. Or sometimes it is possible that to complete the research in short time, we can take up that particular area as a research area. So these are choice of research areas. Now more generally, a good researcher or a potential researcher first identifies a broad area. So he or she may select a broader area or a uh, larger area within his or her subject of specialization that appeals to him or her as a interesting or challenging. At the same time, it is doable. At the same time, it is doable. Maybe with some guidance from a supervisor or advisor or a senior or a mentor. So this is important. First, identify the broader area and if that of that particular specialization, and then based on the interest of challenge, and also it should be doable within the time. And for completing that research, one can take help of his guide, supervisor, advisor. One then scans available literature in that broader area and then limit the area of possible research. For example, The broader area is electrical engineering. Then, so in electrical engineering, what can be done? Then one can go through the literature in that particular problem area to gradually limit the area of possible research. So in electrical engineering, again, there are sub fields like there may be electrical machines, it may be drives, it may be power electronics, control system, and power system. So these are sub fields. So one has to do the literature in that broader area and then limit the area of possible research. And fortunately, this step has been greatly facilitated these days through easy access to database and books as well as articles that have a bearing on the problem area chosen initially. So today we have a lot of sources like IEEE, Google Scholars, and lot of databases are available elsewhere, Springer, Valley. Also, the availability of e-resources of books, e-books are available, even articles are available. So those all will help in selecting or finalizing or limiting our area of research to that subfield. In fact, one can even access documents which spell out as open problems in different areas. So in some of the cases, we find that some of the industries, research organizations float their problems as open problems in the research community, and one can conveniently take out that problems as the part of his or her research, and then identify the sub research problem in that, and then try to find out the solutions. Now, problem areas emerge from discussions among peers or colleagues, attentive pursuit of editorials in newspapers. So some of the problems may be identified through some editorials in newspapers. These are for general statement for all kind of researchers. Then experiences gained by the visits to places not seen earlier and even during the journey. So it may be possible that through industry visits or through visits to some places we can identify some problem. Then thoughtful analysis of some statements by leading scientist or economist or social worker. So through the talks of scientists, economists, mathematicians, one can find out the research area. One's own urge to solve a long experienced problem. So it may be possible that one can take his own interest to solve a long experience problem at home or at the workplace or in the society, and post the similar other resources. So these are some of the resources or some of the sources where one can find out the research area. Now here some sample examples are given of research areas. These are again in general. So first area is investment potential. So we can see here the problem area one. Different states or provinces within a country claim their investment potentials to be quite high, and it becomes difficult for a willing investor to choose a destination based on such claims. Say, for example, in India, one investor outside foreign investor wants to invest, but the investor don't know that which state or which place is feasible for him. Then why that is there is no consensus evidences based on based index of investment potential currently. So there is no index of investment potential currently in the India or in the any one country. Then the National Council of Applied Economic Research got involved a couple of years back and then took up the problem, and then they start working on this, and they have started ranking of the states based on the investment potential. And now one one can easily identify that which state is feasible for them or as per the profit, places, resources available at that particular location, and then he or she can invest in that particular state or province. So this is one problem, and then this is now take up as a problem by the one agency, and then it is giving the ranking for the states. Similarly, Another problem is discrete or optimization problem. Like we encounter complex or an ill-posed objective functions in an optimization problem. It is also possible that some of the variables and relations involved in that problem are ambiguous, that no clarity is there, or intervalued like fuzzy. So existing algorithms do not help in reaching the optimal solution in such cases. At the same time, more and more real life problems exhibit such features in fact. So there are problems where the parameters are ambiguous or intervalued, or those are like fuzzy nature. And to solve such cases, existing algorithms do not help in getting or finding out the optimal solution. And most of the real life problems relate to such problems. So for that purpose, discrete optimization problems in sequencing and scheduling and also in network analysis is taken up. And this kind of problems can be taken up as a research problem, or this kind of area, that is discrete optimization problems. The next problem is, in many large scale sample surveys, a multi-stage stratified random sampling design is adopted. The researcher has to work out a suitable allocation of the total sample size n. Means random sampling is taken, but a researcher has to work out on a suitable allocation of that total samples. So this is another research area and problem. Then next one is, in dealing with highly complex and the same time highly reliable systems, we cannot directly estimate the probability of system failure. So we cannot identify or we cannot estimate the probability of system failure in absence of even a single failure observed. Suppose the system is there and it hasn't observed any failure till date, then one has to estimate the probability of such failure. So this is another problem area. Now this is most hot topic in today's research, that environment and ecology coupled with development have become areas of hot pursuit by researchers, because one problem could be like to develop a measure of biodiversity in plants or animals in a given ecosystem. So to develop a measure of biodiversity, it may be in plants or in animals for that particular given ecosystem. So this is one kind of problem for the environment and ecology. So here environment and ecology is a broader area, and then measuring the biodiversity in plants or measuring the biodiversity in animals is the sub area. Similarly, the broader area may be health and diseases. Health research is one broader area, and sub area we can say that to find out the weights to be associated with different disability categories. So this is again a sub area. So based on this, the United Nations has discussed in its summit in 2015 that they have developed or they have declared 17 sustainable development goals, SDGs, and these are to be achieved by the end of 2030, so that it will end the poverty, and it will promote the prosperity and people's well-being and protect the environment and globe. So from one can also identify the problems within these 17 sustainable development goals. Like first goal is no poverty, zero hunger, good health and well-being, quality education. So this is also one broader area of research. Gender equality, clean water and sanitation, affordable and clean energy. So we see most of the research has been taken out in the clean energy and more penetration of renewable sources in the last 1 or 2 decades we are observing. Then decent work and economic growth, industry, innovation and infrastructure, another research area. Required inequalities, reduced inequalities, then sustainable cities and communities. So this is also one important task as the population is being increased of the globe, and then we need to prepare for the sustainable cities. Then responsible consumption and production, climate action, life below water, life on land, peace, then partnership for the goals. So these are 17 sustainable development goals, SDGs, and the research can take up the problem from any one of these goals and start working on it. And these will be the broader areas. So one has to define again the sub areas of in that particular field. Now coming to the electrical engineering. So these are some broader areas, so research areas like power and energy. So energy is one of the most crucial aspects, and we have just seen one of the SDGs related to this energy, that is affordable and clean energy. So power and energy is one of the most crucial aspects of our world, and from climate change to environmental justice to security and health, power and energy plays a major role. So you can see any sector or any utility, everywhere this power and energy are contributing as a significant factors. Then next one is control system. So application of control includes area like cyber physical systems, biological systems, networks, machines, production lines, locomotions, and many more such. And everywhere this control system is important, and this is again broader area. Similarly, embedded system. Now today's market is booming with the embedded systems, maybe in terms of computers, mobiles, in vehicles, the advanced systems in conventional vehicles, e-vehicles, wireless sensors, medical devices, and then wearable fitness devices, smartphones, and many more. Everywhere we observe this embedded system, and this is again a scope for research in the embedded system. Then solid state devices and nanotechnology is another research area where projects can be taken out. Then robotics and autonomous systems. So in the previous decade, we have discussed about, it is seen that electric vehicles are there, and now we are talking about autonomous e-vehicles. Similarly, in the medical field, signal and image processing and machine learnings are being incorporated to solve the problems, to diagnose and diagnose even for the medicine purpose, radar, defense sectors, and then networking, communication systems. Everywhere these problems are identified, and researchers are solving these kind of problems. So these are some broader areas. Similarly, you can see here, like in electrical engineering, particularly energy networks. So how these networks are operating, how we can improvise in that or make that system efficient is one area. Similarly, high voltage technologies is another area. It may be in terms of AC voltage or DC voltage, and to convert and to transmit that over long lines. So what can be incorporated? This is another research area. Then mechatronics, that is how we can embed mechanical things with electronics and make a mechatronic system so that it will be easily accessible. Photonics, generally used in the sensor technologies. Then power convergence, whether you are converting from AC to DC, DC to AC, or you are converting some mechanical energy into electrical energy or kinetic energy into electrical energy. So this research is being carried out in this sector. Then power electronics. So lot of invention have been made in the last 2 decades in this field, and still it is going on. Then autonomous systems, quadruple helicopters or autonomous e-vehicles. Then communications. So just 5 to 6 years ago, we are talking about 2G, 3G, and now we are talking about 5G implementations. Then control system automation is being implemented in most of the industries, and everywhere this comes, this problem or this area is identified. Digital signal processing, then electrical materials. So solar is one, or even battery is another thing where the research is going in the field of research materials for those particular preparing those particular devices. Then electronic device like microcontrollers, microprocessor, DSPs, and all that, VLSIs. Then there is scope for working in sensor and sensing systems also, or in system integration, or in the themes of different algorithms. So these are some sub areas in the electrical engineering where one can take up the problem as a research problem. So after research problems, we can again sub problems. We can identify some sub problems. Like in power electronics, one can take up the power dense converters, or how the energy can be harvested. So this is another problem. Or how we can convert these sources, voltage sources, HVDC or HVAC. So these are the subfields again in the power electronic field. Similarly, for the power convergence, what improvements can be done in the electrical machines, or whether it may be AC machine, DC machine, or can we design such a machine which will be very efficient and can be used in the way particular applications. For example, we see that uh, permanent magnet DC motors are used in EVs. Then now VLDC motors are being used, and then there are results where induction motors are being used. So research is carried out in machines also for various applications. Similarly, superconducting applications. So what kind of conducting materials or what kind of superconducting materials are used to do the power conversion. Then this is a hot topic again, energy storage, because we have bulk amount of solar in today's world, and but we cannot store it, or the storing capability are not that much efficient. So this is scope, one way of doing research, one area of doing research. Then in the control system, one can pursue the research in control theory in terms of theoretical uh, concepts, or one can apply the control system principles in the process controls or manufacturing, even in the robotics field. Then in the high voltage technologies, transformers are very important to step up or step down. Then insulations, then conditioning monitoring is another important thing. Also here in the control system, we can uh, see automation and control is one area where one can take up the research problem. So these are some of the fields areas of research. Then in electrical materials and renewable sources, 2D materials are being taken as research problems. Then dielectric materials, how we can improvise in transmissions and distributions. Then solar energy and wind energy as a part of renewable energy. Again, in that subfield, solar energy, as I previously talked, that materials for solar panels or preparing solar panels. So there is a scope for research in solar materials or even in the battery materials. And then renewable energy sources. So these are two prominent sources: solar energy and wind. But apart from this, there are technologies like fuel cell, then uh, hydrogen. These are all other different other renewable energy sources are incorporated in today's technologies. Now, the most hot research problem in today is electric vehicles, and this is again a broader view in the electrical material and renewable sources. But again, in electric vehicles, one can easily find out many research problems like battery management systems, then what kind of machines can be used, then how one can improvise the efficiency, or how one can incorporate sources, maybe AC source, DC source, and what can be done from that AC and DC source, or whether we can supply it to the grid. So, like V to grid research is being carried out, grid to vehicles and vehicle to grid. So, these kind of research are being taken in the electric vehicles itself alone. So, and these are again in BMS again two kind of researches is done: monitoring and health monitoring of battery management system, or one can take up the based on the materials. So what kind of materials can be used for the battery. Then in machines also again two kind of research can be taken. For example, how to control this and what kind of design machines one can use. So these are all different actually research problems in this particular field, that is electric vehicles. Then similarly, mobile robots. This is again uh, one good area. Then in autonomous systems and system integrations, we might have heard, you might have heard unmanned aerial vehicles, UAVs. So scope for this uh, working on these problems: unmanned underwater vehicles, UGs, then unmanned ground vehicles, UGVs. So all these are important if we come to defense sector. Then similarly, resilient interdependent systems. So interdependent systems are there. Imaging systems. So scope for image processing in scope for doing research in the image processing. Then advanced measurement systems. So measurement systems may be in terms of sensors. So advanced sensors are being uh, developed in today too, and these advanced sensors are being implemented in various systems, real life applications, and making the solving the societal problems. So here are some examples in power system. So we'll just read out what kind of problems we can, or we can restrict, limit our research scope. So for example, power system inertia estimation. So one can review of methods and then impacts of converter interface generator. So this is the problem, power system inertia estimation. So for that, review of methods and then impact of converter interface generations can be identified. Then another problem is technical barriers for harnessing the green nitrogen. This is a power system perspective we can identify as a problem. Then optimal analysis of a hybrid renewable power system for a remote island. So for a remote island, how we can integrate renewables with conventional sources and make an hybrid renewable power system. Then another example is power system hybrid dynamic economic emission dispatch with wind energy based on improved selfish algorithm. So different kind of algorithms are being developed to solve the problems. A sustainable energy distribution configuration. for microgrids. So for microgrids integrated to the national grid using back-to-back converters in a renewable power station. So we discussed that solar and wind are two major sources of renewables, and one can easily interface those sources by using back-to-back converters, and then integrate this with the national grid. And so first form the microgrids and then integrate with the national grid. Then an optimization based strategy for solving optimal power flow problems in power system. So with stochastic solar and wind power energy. So these are research uh, problems in that particular power system or renewables field. Then optimal control of integrated hybrid power system with FAC devices. So these are some of the examples of the research problems. So the next point is finding a research problem and through some tips. Okay, so we'll discuss in this about the inception to conclusion. So from start to end, what are the points? Then what are the various scenarios? What are the features of good problems? Then strategies for finding good problems, then logistic issues and risk assessment. So these are some major points we will discuss uh, in this session through some of the examples and demonstrations. And what are the resources available while doing this? We also see those examples. So we'll stop here and we will continue with these 6 points in the next session. So in today's session, we have seen we revisited the research, motivation for the research, and then again we revisited the research problem, and then we have taken one illustrative examples of how one research problem can be identified through a mathematical example of perfect numbers, and then how what is the significance of solving that problem. So it is the research problem has to contribute to that particular field of domain, research domain. Then we have seen what are the necessities of defining the good problem or research problem, and how it will affect or how it will relate to the researcher. And then afterwards we have seen choice of research areas, and initially we have discussed the general areas of research in the broader perspective, and with respect to 17 SDGs, what kind of problems can be identified is also seen, like clean energy, then no poverty, gender equality, quality education, clean and water sanitations, then climate actions, industry innovations. So these are some of the broader areas or goals, and through these goals, one can identify the subfields, and from subfields, one can try for the exact problems, research problems in that particular field. And afterwards, we have seen the major areas in electrical engineering like power energy, control system, embedded system, solid state devices, robotics, signal processing, and energy networks, high voltages, power convergence, power electronics, then autonomous systems, control system, DSPs, materials, and sensor technologies integrations. So these are some subfields again. Again, in the subfields, one can take up the problem from the power dense converters, energy harvesting, convergence, AC/DC convergence. In the power convergence, battery management systems, supercapacitors, superconducting applications, machines. Then in the control system, one can go for research in the control theory, process control, automations, robotics, SCADA system, high voltage, and in EV also we can. I will discuss a lot of scope for the research. Then unmanned vehicles. So and some power system examples. So this is about the choice of research area. Now in the next session we will discuss about the finding the research problem with some illustrations and what are the different resources available and how we can utilize those to frame our research problem. So we stop here.